So here is another question on linear inequations in one variable. So it is given that if the replacement set is the set of integers between -6 and 8, find the solution set of 6x minus 1 is greater than or equal to 9 plus x. This is the first bit. The second bit is 15 minus 3x is greater than x minus 3. So the first one, okay, 6x minus 1 greater than or equal to 9 plus x. So here what we'll do, we'll take this plus x, take it to the LHS side, will become minus. We'll take this minus 1, take it to the RHS side, will become plus. This will not affect the sign of inequality, it will stay the same. So 6x minus x greater than or equal to 9 plus 1. That implies 5x is greater than or equal to 10. Again, we'll divide both sides of the inequation by the same positive number, 5. 5x by 5, 10 by 5. That implies x is greater than or equal to 2. Okay, this is the solution of the given inequation. Now here our replacement set is the set of integers between -6 and 8. So the replacement set is, here the interesting thing is that it is the integers in between -6 and 8. -6 and 8 are not included in it. Okay, so starting from -5, then -4, -3, up to 0, then 1, then 2, up to 7. Okay, 8 is not included, -6 is not included. So here it is greater than or equal to 2. So it will start from 2 and end in 7, this much. This is the solution set. So the solution set is 2, 3, 4, 5, 6, 7. This is the choice, okay, this is the pool from which we have to select our solutions which will fulfill this criteria. So, okay, so the replacement set, they are the options from which we have to pick the solutions which will fulfill this criteria of the inequation which we have solved. So x should be greater than or equal to 2. We have to pick the solution from this replacement set. So here it is 2, 3, 4, 5, 6, 7. These solutions fulfill this criteria. So this is the solution set. Then the second bit, which is 15 minus 3x is greater than x minus 3. 15 minus 3x is greater than x minus 3. That implies we'll take this minus 3, take it to the LHS side, will become plus. We'll take this minus 3x, take it to the RHS side, will become plus. So 15 plus 3 is greater than x plus 3x. That implies 18 is greater than 4x, or we can write it as, that implies 4x is lesser than 18. Same thing. Now we'll divide both sides by the same positive number. So here 4x by 4, here 18 by 4. Okay, so that implies x is lesser than 4.5. So here a decimal value came up, but our choice is from the set of integers between -6 and 8. So lesser than 4.5, so it means from minus 5 to 4. All the numbers including minus 5 and 4, they are the solution set. So in this case, the solution set is minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. This is the solution set which satisfies this criteria. X should be lesser than 4.5 from the replacement set of this. Okay, so this is the solution set and this is the solution of the given inequation. Okay, so here is another question on linear inequations in one variable. So it is given that if the replacement set is the set of real numbers, find the solution set of 5 minus 3x is lesser than 11 and 8 plus 3x is greater than or equal to 28 minus 2x. This is bit 1, this is bit 2. So here the replacement set is real numbers. So far we have dealt with natural numbers, whole numbers and integers. So here the solution set will be represented in a different way. So first, 5 minus 3x is lesser than 11. So here what we'll do, we'll take this plus 5 and take it to the RHS side. It will become minus. So that implies minus 3x, sign of inequality will stay the same, then 11 minus 5. That implies minus 3x is lesser than 6. So here we will implement another rule of handling linear inequations, where if the sign on each side of the inequation, that is both LHS and RHS, they are changed, then the sign of inequality reverses. So here, if this minus 3x is changed to plus and 6 is changed to minus 6, so this lesser than will become greater than. That implies 3x is greater than minus 6. Okay, 3x is greater than minus 6. Initially it was minus 3x lesser than 6. So here it becomes 3x greater than minus 6. Now we will divide both sides by the same positive number. In that case the sign of inequality, it will stay the same. So by 3 by 3. That implies x is greater than minus 2. Okay, x is greater than minus 2. So this is the solution of the given inequation. So here the replacement set is the real numbers, the entire set of real numbers. So here we have to represent the solution set in this way. X with x greater than minus 2 and x belongs to R, that is real numbers, where R the set of real numbers. This. Okay, so this is the representation of the solution set. Here, as the replacement set is the entire set of real numbers. So it is very difficult to specifically mention everything, because all of the things come into play: rational, irrational, then the other things, integers, whole numbers, everything comes into play. So it is very difficult to represent each distinct point separately, so we'll write it in this way. So the second bit is 8 plus 3x greater than or equal to 28 minus 2x. Okay, so let's do that. 8 plus 3x is greater than or equal to 28 minus 2x. So here what we'll do, we'll take this minus 2x, take it to the LHS side, it will become plus, and we'll take this plus 8, take it to the RHS side, it will become minus. So that implies 3x plus 2x is greater than or equal to 28 minus 8. That implies 5x is greater than or equal to 20. Now we'll divide both sides of the inequation by the same positive number. So here 5x by 5, here 20 by 5. That implies x is greater than or equal to 4. This is the solution of the given inequation. Again, as the replacement set is the entire set of real numbers, so here we'll represent it in this way as we did it previously. So solution set is represented as x with the given conditions. X should be greater than or equal to 4 and x belongs to the set of real numbers. Okay, so this is the solution. So here is another question on linear inequations in one variable. So here it is given to solve this given inequation represented as x by 2 minus 5 is lesser than or equal to x by 3 minus 4, where x is a positive odd integer. So in a way it has given us the replacement set where x is a positive odd integer, and from this we have to find out the solution set from the solution which we will get here. Okay, so here first what we will do, we'll bring the x on one side and the constants on the other side. So x by 3 will go to the LHS side, will become minus, minus 5 will go to the RHS side, will become plus. So x by 2, first let us write it in the proper way, okay, x by 3 minus 4. So here that implies x by 2 minus x by 3 is lesser than or equal to 5 minus 4. That implies here it is 6, so it becomes 3x minus 2x is lesser than or equal to 1. Okay, that implies x by 6 is lesser than or equal to 1. So here we'll multiply both sides of the inequation by the same positive number. So in that case the sign of inequality will stay the same. So here if we multiply 6 here and also we multiply 6 here, so we'll have x is lesser than or equal to 6. So this is the solution of the given inequation. Now the replacement set is the set of positive odd integers. So 1, 3, 5, 7, 9 and so on, like this. So from this we have to find those solutions which satisfy this criteria. X is lesser than or equal to 6. So that means we have these three solutions, 1, 3 and 5. So the solution set is 1, 3, 5. Solution set for the given inequation. Okay.